So let's draw a graph in Excel. So suppose our graph data table for which we'll be drawing the graph has 2 columns, which I am writing out for you. Okay, so these are the 2 columns X and Y for our data set. So what we'll do is we'll select the data set, then we will go to insert, scatter, this option scatter with smooth lines and markers, and draw the graph. So we have a straight line graph for our data. Now it's very important to mark the columns. For that we will go to layout and axis title. So first let's label the vertical axis. We will label it with a horizontal title. So axis title, in this case, the Y axis has log of row. So from symbol we will put in row, log row. Similarly, we will also label the X axis, where we will put in whatever label we want to set to it. Here, of course, along the X axis, we are plotting 1000 by T in Kelvin inverse. So we'll write that. Okay, so labeling the axis is complete. Next, you see this graph is a straight line graph. But for this particular experiment, when you will draw the actual log row versus 1000 by T graph, the graph would be linear for high temperature zone. High temperature means lower value of X, lower value of 1000 by T. So in the lower X or higher temperature zone, the graph would be linear, and in the lower temperature or higher 1000 by T zone, the graph would be ogive or curved. So I'll tell you how to deal with it, but let's see how we find out the slope for this linear graph. So again, from layout, I'll choose the option trend line, go to more trend line options, and of course, we'll keep it to linear because the graph is linear, and display equation on chart, we'll tick it, and the corresponding equation is there in the chart. So this is the equation of a straight line, y is equal to mx plus c. Here the slope m is 2 and the intercept c is 0. So we have found the slope of the graph to be 2 in this case. But for you, I said for this particular experiment, the graph is linear in a certain temperature zone and ogive in the other temperature zone. So first we'll draw out the full graph and find out the region in which the graph is linear. It's important. We'll identify the region in which the graph has a linear behavior. Then we will select out only that part of the data set for which the graph is linear. And using that part of the data set, we'll draw a second graph, which will be now totally linear. And from that totally linear graph, by the method I just showed you, you will find out the equation of the straight line and the corresponding slope. And you have learned how you will use the slope for your further calculations to find out the band gap of your semiconductor. Okay. Now I will put before you some simple questions regarding this experiment. So if you have understood the experiment well enough, you will be able to answer the following questions. The first question is the resistivity of a semiconductor. These are the 4 choices. Choose the correct one. The next is the advantage of using the 4 probe method over the 2 probe method is, again, you are given 4 options. Please choose the correct one. So thank you for paying attention and hope you enjoyed the experiment.